Hello and welcome to another Solana tutorial. Today we're gonna talk about building programs in C. I think I did that right. You know, C, the programming language. Usually we write Solana programs in Rust, but we can write them in C. I've just never done that before. So it's a good time to get started. But why would we want to do that? Well, one reason could be there are more C developers out there than Rust developers. So you might know C, but you might not know Rust. However, in that case, I would even recommend that you learn Rust. Rust is a really cool language. I like it. I love Rust. But why would you still want to develop in C then? Well, efficiency. The one reason why C is still around after all these years. Efficiency. I mean, there's a reason why most of the embedded system stuff and a lot of the high performance stuff is written in C. C is just a more low-level language. And the closer you are to the hardware, the more specific you can be and, take advantage of how the hardware actually works. The more you abstract it, the easier it gets to program, but therefore it gets more inefficient because it adds more overhead. So this will always be a trade-off. I'm not saying developing in C is better than developing in Rust. I'm saying it could be more efficient. It's probably more difficult as well, because in C you need to do the memory allocation manually and all that stuff. C is not a language that is particularly developer friendly, but it might be worth it. If you need to write a program that uses fewer CUs, using C might be a good alternative. I mean, there's a reason why they write Fire Dancer in C. That language just has been around and has been battle tested, which also means that the C compilers are more mature. I'm not saying that the Rust compiler is bad, but it just hasn't been around as long and it hasn't been optimized as much. The GCC, the C compiler, has been through many iterations and is really good at optimizing code. Like the bytecode and optimizing that. So compiling C will just result in more efficient bytecode. The only way how we can be even more efficient is by writing bytecode ourselves. Coding in assembly. When you read and write registries manually. But that is really a pain and you probably don't want to do that, except maybe for really tiny programs. And we can look at that in a future video. I might want to look at that in a future video, coding in assembly. But today we're just going to have a look at coding in C. And I'm not going to do a deep dive. I'm just going to give you the motivation why you might want to code in C, which is what I just did, I hope. Then I want to have a look at how C programs on Solana look like and how we can deploy them. We're not actually going to write our own C program here. This again might be a topic for a future video, one step at a time. So as I said, it's always a trade-off between being easy to develop and being efficient. And on the top we have frameworks like Anchor, which make it easy to write code, but therefore they're not super efficient. More efficient is to use Rust directly, and more efficient than that, C, and even more efficient than that, assembly. But this is then really not easy to code. It will take you a lot longer to write a program in assembly or in C as compared to doing the same thing in Anchor. So it is a trade-off. That's why we have choices. If there was one best thing, then we would just use that. Alright, enough of the intro. Let's actually get started and have a look at what a Solana program in C looks like and how we can deploy it. So, developing with C. Getting started with Anchor. This is the opposite of what I want. There used to be programs lang C, but nope, not anymore. It gets me to Anchor. Wonderful. Very great. That's not at all what I want. Maybe there's something in the program examples. On-chain program examples for Anchor, Native, and Python. There, Solana program library examples. In the SPL, we have examples in C. Look, there's Rust examples and there's C examples. The examples in this directory demonstrate various Solana program mechanisms. They are for code reference only, are not end-to-end working examples. Current C-test frameworks are very limited, so not all functionality is fully tested. Yeah, so that's another thing that you might want to consider. Since Rust is the main language, the whole testing frameworks and everything is not fully built out. I don't think a lot of people are writing programs in C, but it is possible. And that's what I want to showcase today. And then you can make your own choices whether or not it is worth it to you to code programs in C. Or maybe you also just want to code a part of it in C and see how you can include that in your Rust program or have a sub program, but having unnecessary CPIs is also not what you want if you want to. Yeah, so I'm just gonna showcase what we can do. So let's see what we can do here with C. What we need, make the GCC compiler and Solana in version 1.4, which is pretty old, so we have that. So there are examples for transferring Lamperts, which is going to be the simplest thing ever. That's probably what we want to have a look at. Then there's also CPIs, custom heap allocation, logging. Well, that's probably going to be the most simple because it will just sol log include Solana SDK.h. Interesting. That's what we'll need to include. That will have all of these things. Now, I'm not going to teach you C, obviously. And if you know any procedural programming language, then you will understand most of what C is. So if you have background in, Java or something like that, then you can read most of C. Yeah, so that's how we log stuff. And we can log the compute units. Yes. Seen that in a previous video. Log the input parameters. Cool. So where do they come from? They come from sol parameters. How does it make that the entry point? Oh, that's how it makes it the entry point. It defines entry point with a uint array input. Pointer or array really is the same thing in C. Not quite, because it depends on the size, on how we can treat it as the same thing pretty much. Then we have sol account infos. I don't fully understand that. Like, what is it doing with the input? It's ignoring that. Do I need to get this? Let's see what the transfer Lampert does. Probably the same thing with the entry point. Defines an array of 2. It expects 2 accounts is probably what that means. Oh wait, here it puts the input. Did it also do that in the other example? Was that just blind? Oh yeah, it does use the input. Sorry, that's literally here. Okay, cool. So it does use the input and it does use those parameters, which are then the account infos, I guess, a number of accounts. Then it calls transfer with the parameters, what that does. And it could probably read the transfer amount. That's actually a good goal that we could set for ourselves today. We want to deploy this program, but with the addition that we can specify the amount of Lamperts to transfer, because then we would need to figure out how to read from that input. So then we did a little bit of coding. Yeah, that's actually a good goal. I like it. So yeah, when it calls that transfer, what it does for now, it says the first one is the source account and the second one is the destination. So we check that we have at least 2 accounts, which I think is also done in here in a different way though. But this would make it fail if we have more accounts actually. Yeah, we have an account info. It's just called sol account info. The first one and the second one. That's just how C writes it. You have to. Parameters is a pointer. So we need to use that arrow. We need to first deref it. And then the deref account, we can say .ka. But the short writing is with that arrow. And then from that thing, we take element number 0, which is the object itself, and therefore we need to get the pointer of it, such that we have a pointer. C is fun, but it's been a long time since I developed C. Anyway, I'm not going to teach you C here, I'm just checking what's happening here. So this sol account info has a Lamperts field, and that apparently we can directly modify. So that I guess that must be an account that the program itself owns, because otherwise it needs to do a CPI to the system program. And then it can also, on any destination account add Lamperts. But this, the source account, it must actually own. If we don't own it, then we would need to do it through a CPI. And there's probably an example in here. Yeah, with system program. Wow, it's manually building that. It's doing an allocate. Okay. That's why it writes 8 into the first byte of the data and then the first 4 bytes actually. But you just need to write the first byte because it's just 1 byte number and it's little endian. Yeah, so basically manually building the data and then the metas with the public key writable and signer, or the other way around, not sure. Arguments, and with that we build the instruction to which program, which arguments, so which accounts, how many there are, because in C we're not working with vectors, we're working with arrays or pointers, and therefore we will always need to pass in the actual length of it, because C arrays, they don't store the length of the array. So we need to always pass that in as well. That's funny. So the array size and then the data and of course the data size. It's funny. And then we have that instruction, and then we can call the sol invoke signed, which probably comes from this header file again. And there we put the instructions, probably the accounts and the accounts number, because here we just have the matters, and then here once again we need the account infos when we invoke. The signer seeds, oh yeah, because it's signed, it's a signing for a PDA. So we use signer seeds as well, static bytes in this case. Cool, so you can do a lot of things in C as well. Probably you can do pretty much all the things that you can do in Rust. It just is a bit more complicated if you're not used to it. And there's less documentation on it because fewer people actually write programs in C. So therefore it's going to be way more difficult to write programs in C. But it is possible. And I kind of like the challenge that I set myself to deploy this program and change it up a bit. Can't be so difficult. Let's do it. Gonna let you see how long it takes me to do this. Time is running. I would expect I'm done in an hour. Okay, step 1. Well, first of all, we need make and GCC. I don't have that installed. This thing has examples. Yeah, just to make sure we have the newest version. Not like they changed in the past, I guess. 2 years ago, but still. And let's open it. The transfer lamperts. Let's open this one. Oh, see, I missed you. Do you want to install that? Yes, why not? It's actually good to see some C. I actually missed this. I haven't coded in C in a long time. So, you're complaining that this doesn't exist. How do we get this? I mean, wait, there's a make file here, and it includes local share Solana install spfmk. Let's check if that exists. Yeah, I have that because I have a valid Solana installation at 1.18.18. Do I know what's in there? Well, I mean, great, that's like makefile stuff. But does that include my dependencies though? I mean, probably somehow this will include all of the dependencies then, yes? I still need to somehow... What would happen if I say make? Nothing to make. How do you call a makefile? Let's see the other... Oh, here it does make something. Why does it like that makefile and not mine? What if I just want to build this one program? What if I were to start a new project? Then I copy those 3 files. Then maybe I will put the files in a source folder. Ah, that changes stuff. If there's a source folder, that's better. Okay, cool. It does create ourselves the target deploy, where it even creates key pairs. That's amazing. Even compiles the test file to a... Yeah, but how do I tell you that? Where does that even sit? I mean, it's probably somewhere also in my Solana installation path. It would be great if I have that, because then I could, work properly with all those things, which for now I can't. That would be good to figure out. There we go. That wasn't too difficult to find. In the include, it has a Solana SDK.h. So I just need to somehow get that into my include path. How do I do that? Quick fix. Edit include path. Include path. This thing. There we go. Cool, we have that. Which also means, hopefully, now we can say sol account if wonderful. Look, we have all the types. I love this. Love this. Okay, but before we actually change the program, we attempt to deploy it. And in order to deploy it, all we gotta do is be able to compile it. And we already saw how that's done. I mean, basically, fine, install it then. What was I just saying right now? Through the make file, we can just make it, because I have GCC installed and I have make installed. So I can just make... No, I cannot. Maybe because it was already done. Hold on, if I delete this. Yeah, if I delete this and then make, then it will do something again. Cannot find entry symbol entry point. Not setting start address. No. I don't know if that is a problem. Maybe it doesn't need to find entry point because that's something Solana specific, that then when it's executed on chain, the entry point is what is triggered. So it's okay that we don't find it. Something like that, maybe, I don't know. But yeah, it says to deploy your program, just use this. The test, actually I don't need the test. Forget about the test. And then if I make, then it just makes this. There we go. Solana program deploy, this one. It also already writes me a key pair, and I could of course have my custom key pair. C, program to transfer lamperts. CPTL. Yeah, like that. There is no L, you're right. There you go. CPTL. And we're just gonna copy this to target deploy key pair. And then we do the thing that it said, that are now cleared. Solana program deploy, I mean, easy as that, right? We do need a Solana config though, so hold on, I'm gonna get myself another key pair, the deployer. Ah, there is no L, damn it. Hacker house. And we're gonna Solana config set ourselves to devnet and use this key pair and Solana airdrop ourselves some sol. And then we can do the thing with the Solana program deploy, transfer lamperts, except we can't. Multiple or no text sections. Consider removing LLC option. ELF error. Interesting. Now that's where it gets interesting, because that's where I have no idea anymore. I don't even know what ELF is. Executable and linkable format. Multiple or no text sections. The LLC is the linker, right? LLVM bytecode into assembly language. Assembly language output can then be passed through the native assembler and linker to generate the native code. Yeah, this is more complicated because there's so many steps. I think they're also in Rust, but you know, you compile from C to assembly. I don't remember the steps. I learned it at uni. I even taught it at uni, but I forgot. Then you have the assembly code, then you link it, and then you build it for the given hardware, which in our case is this. So where can I add or remove this option? Maybe it doesn't like that, but I have no idea what all of that means. I'm not ever looking at that low level. Anyway, what does that help me? Nothing. See, that's why Rust is also easier, because at least if I have an error there, I can just Google it. Oh, there it is. Trying to deploy anchor. I mean, I think that error comes from something else just not being specified. It probably needs some more. You know what? Let's see if in here, with those programs that I made, if I could deploy those. We should have the transfer lamports SO here as well. So can I be like Solana program deploy transfer lamperts from here? This, okay, so this one, it can deploy. So we're just missing something else that we have here in this example that we don't have the way I do it with just this file. So I'm clearly doing something wrong here, but my question is, what's the difference? In here, there's no difference. I mean, I have the tests, but I don't think that makes the difference. What else do we have here? More programs? I don't think so. What else do we have here? Here's the make file, which looks the exact same. So why does that one include it correctly and mine doesn't? 2.5 kilobytes. And this thing only has 1 kilobyte. Interesting. So yeah, I'm missing something in this compilation. Maybe I shouldn't have taken the test. Maybe that test was actually important. I don't think so. Let's try. Nope, still the same. What else is the difference to this one? How do you manage to build this one properly? Maybe I need a folder. Hold on. Maybe I need source and then program name. Source, new folder, transfer lamperts. That's the program name, and this goes in here. Maybe that changes stuff. It looks different. And it's also not complaining about the entry point anymore. That looks better. And I don't think I need the test, because then it's testing that. That's cool though. So I make clean one more time, and then I make one more time. Cool, now it's not complaining about the entry point. Cool, yeah, that's good, that's a good sign. So I just needed to put it in a folder. Things you just gotta know. Okay, good. Let me copy that key pair again. And then I say Solana program deploy. Yeah, and we can deploy this program. Look at this. The C program to transfer Lamperts is executable, deployed. Wonderful. Check this. And now we can call it. That I guess I will need to do manually. Let's write a quick script. Solana Web3 at RC1 in version 2.0.0. The new Web3.js. We're gonna load our key pair. Just gonna borrow that code from a previous video where we learned how to send transaction with the new Web3.js, and then we just need to build the instruction, which is an instruction. And basically we need the program address. Okay, address, that's my program. And accounts and data. Data, we're not using anything, so don't need no data. And the accounts though, they will now need to be, well, the two accounts, one account that belongs to the program. How do I get a new key pair? How does the new Web3.js work? I don't know. That's why I'm working with it, so should I get practice in how that all that stuff works. Generate key pair signer. That's probably what I want. And then I will need a first instruction, but let's assume that account was created and assigned to the program. Then I can use the new account address here. The role is writable. Oh, any? You kidding me? Account role, there we go. Writable signer. No, in this case it's just writable. It does need to be a signer for creating the account. And then after that we do a second one. So that was the source, and that's the destination, and the destination, my key pair. I'm gonna give you my key pairs, and that's also writable. Just needs to be writable. It will become a signer here when we set transaction message fee pair signer. So that will work when that new account already exists. However, since it doesn't exist yet, we need to do a create instruction, which we can import from Solana program system, something like that. Yearn add, does that exist? Looks good. Yes, and in here we have a create account instruction. Get create account instruction. That sounds good. Payer will be me. Lamperts, it doesn't really matter. It just needs to have enough. So let's say, I don't know, 0.1 sol. Why not? Oh, payer needs to be a signer. Okay, sure. The new account is the new account address, and the space, oh, it's just a program account with 0 data, so it has, well, actually 0, then 0 data is 0 data. We don't need to store anything on there. And the program address, oh yeah, again. And I'm so used to, from the old Web3.js, that I always specify the address and not the signers, but it needs to be a signer. It's so smart. But that way, then I also, since I put in here the signer, I don't need to manually add it here, I think. So then when I sign, it will already sign properly. We'll see. But that's, oh yeah, we need to add that instruction as well. First the create instruction and then our program instruction. Let's see if that would run. No. Oh, the RPC subscription. What? Throwback to last video. We also had that. Cannot find module WS. Require WS. Where are we here? Solana RPC subscription transport with WebSocket. Can we just yearn add WS? Yeah, that'll do. Ha! And I get a transaction signature. Doesn't mean that the transaction is confirmed. Now it's confirmed though. Nice. Check this. We go to DevNet. We pump in our transaction ID and we executed this transaction where we, the deployer, paid the 0.1 Lampert for their account. The 0.1 Lampert went on this account, but then later 5 Lamperts were also transferred out back to me again. Oh, this is fun. So first we created that account with 0.1 Lampert and then we called our C program to transfer Lamperts with no instruction data but those 2 accounts, and that thing then actually transferred the 5 Lamperts. So it works. Our program that we've written in C, well, that somebody else has written in C and we just deployed, it works. We can deploy a C program. Isn't that cool? Look at that. That nice little program, we deployed it and we executed it. It actually works. Isn't that cool? And we could change it to 9 Lamperts and then make, oh, I'm in the wrong folder. Make. There we go. I make and then I deploy again. 3 transactions. Did you see that? Did you see how it just took 3 transactions? That's ridiculous. Hold on. I mean, because it is so small, I mean, it's just 2,500 bytes. In 3 transactions, you can pump that on chain. That's pretty small. And then if I run the transfer script again, new transaction, there we go. This time we transferred 9 back. And it consumed 104 compute units. This entire program invocation consumed 104 compute units. That's less than an instruction to the system program, which takes 150. Wow. Wait, what would a comparable one, if it was written in Rust, do? Do we have a comparable program that does the same thing in Rust? In here maybe? Let me open the entire SPL. Examples, we also have the Rust stuff. And there's also a transfer Lamperts, which, you know, probably does the exact same thing. Yes, it transferred 5 Lamperts. Can I deploy this? Can I just cargo build them? And it's also called transfer-Lamperts. So it's gonna overwrite the other one, I guess. Okay, let's see. Target deploy. Oh, that's still the old version. SPL example transfer Lamperts. Ah, this one. The SPL example transfer Lamperts. But it didn't rebuild it today. Cargo build SPF. There we go, now you rebuild it. SPL example transfer Lamperts SO. And we see this thing, the program itself already has 20 kilobytes versus 2000. That's almost a 10x just from the program size, because this is a Rust program and this is written in C. But they don't do different things. They do the exact same thing. And just to demonstrate, Solana program deploy, if I put that on chain, and now have this program, the GIE, then I would execute my script with this program, get a transaction, get it confirmed. Let's check it. 600 total. It's still not a big, yeah, it does the same thing, transfers 5 Lamperts back. Still not a big program and still just a tiny amount of CU, but a 4x, like 400 compute units for transferring the 5 Lamperts. It doesn't do anything else than that. And it's a 4x in compute units consumed. Just because C is so much more efficient. And I can't name you all the reasons why C is so much more efficient. I named a few. I'm not an expert myself. And maybe it's not even important why it's so much more efficient. Maybe the only thing you need to know is that it is so much more efficient. So if you really need programs that use fewer compute units, maybe you do want to write your programs in C, which by itself is a challenge. So speaking of challenge, that reminds me, I wanted to make that a variable that we get from the parameters somehow, although the parameters are the accounts, so we will need to change it up a little bit. I want to change up my program a little bit such that we can use some input data, because I don't think it's going to be so difficult. And again, that's how I learn, right? I take something that exists and I change it a little bit until I get to a point where I can write C programs myself. But for now, I'm just going to make assumptions and I'm going to assume that this is the byte array that comes in as, you know, my input data from an instruction. And I'm not even going to do something fancy here. I'm just going to read 8 bytes as a U64. And that's going to be the amount I transfer. Little endian. So, I mean, we can start with literally 1 byte. This would be the easiest, but then the maximum I can transfer is 255 Lamperts. But for this first example, it's gonna be right, step by step. So we just take 1 byte. I will, however, need to pass in either the entire input or the amount. What would I do here? I think I would put the entire input. Here I would still give you the entire input. Keep that in here. And then here to get the amount, How does C work again? Const, then the data type, which is uint64. And now would just, read the first byte and I parse that to a bigger data type. So that should automatically transform. And then I just use this amount here and here. It needs to be the same, obviously. And that should do the trick, actually. Let's make it, deploy it in 3 transactions. This is so much. Oh no! What? I still have enough balance. Account data too small for instruction. Oh, I need to resize my program. Oh, this is so annoying that it doesn't do that automatically. The CLI should learn how to do that. Feature request. How did that go? So the issue, in case you don't know, is that my program, this one, the executable data, which lives here, has a size of exactly the size of the program. And now the size of my program increased. Let me show you. Target, deploy, transfer Lamperts went to a little more, actually very insignificantly more, a few bytes more. But with the overhead, it just about bumps the size there's a bit more data in here because it also needs to store the update authority and whatever. 2504 bytes. So 45 bytes are more. So we're basically missing 8 bytes here. We're missing 8 bytes. I need to resize my program account for 8 bytes. Okay, anyway, I wanted to look up how that works. Extend. Solana program extend the program ID and the additional bytes. Okay, program extend my program ID and 8 more bytes. This is ridiculous. But there we go. We've extended it for 8 more bytes. If we look into this account now, it now has 2557. And now we should be able to deploy it. Let's see. Yeah, wait. Yeah. This is ridiculous. But yeah, it's fun. Okay, now that we have deployed this program, let's do our transfer again, but to our program. It's not going to work because this is not going to be correct and the instruction is going to fail on us, but we will just let it fail on us for now. Oh no, it confirmed. Hold on. Maybe. Oh yeah, it's C. C doesn't care. Hold on. Wait. Still did that. But by the looks of it, it transferred 2 Lamperts back. See, here's the thing. And that's one of the issues with C as well. Why, Rust is safer in a way as well. Because my C program here doesn't care if I access some memory that is somewhere completely different. As long as there's something there and I don't get a seg fault, C will just let me do that. And that's exactly the trade-off we have here again, right? In Rust, if I would do that, it would fail. In Rust, in this example, in this processor, if here I would use the instruction data, I'm gonna do the same thing. I'm gonna let a amount u64 be the instruction data byte 0, and I do that. First of all, it might already complain here. Yep. So first I already need to tell you that you should make this byte into a u64. But then let me compile this. Let me deploy this in 21 transactions. Same thing. You're being annoying. Solana program extend this one. I don't know for how many bytes, but here have 100 bytes. I don't care. Just let me deploy it. Still not. 100 seemed so many. But you now have 20k 900. Before you had 20k 500. Fine. Have another 500 bytes. I don't mind. Just let me deploy my program. Cool. And then if we were to call that program, then my expectation that, yeah, there we go, that this wouldn't work. It wouldn't even simulate because it panics because we have an index out of bounds. Rust checks those things. Hence, it uses more compute, obviously. But therefore, it's also more secure. In Rust, I would see, oh, right, I'm accessing an index that I shouldn't access because there is no data there. Rust checks those things. But C, my program is like, no, I'm gonna run this no issue with my program. there you go. You can do whatever you want. I'm not gonna check any bounds. I don't even know how long my data is anyway. So yeah, it's different. And that's why it's more efficient. But it just does fewer checks. And in this case, apparently it transferred 2 Lamperts, I guess. Because whatever comes next seems to be number 2. We're reading some data that we shouldn't read. So in order to fix this, I should give it the correct, well, really I should, fix my program that it does some checks here and not just read any byte where it doesn't know if that's even correct. But also I could just, use some extra data here and tell it to transfer 42 Lamperts, and then it executes this transaction and we will see, oh no, same thing, which means maybe the input is actually something different than I think. So maybe my assumption of this is the literal input data is wrong, which it probably is, since it probably codes the length of all the input as well somehow. But it's weird that it's still 2. Does it change if I have more data here? No. Damn it. We need to figure out what... I mean, my next best guess would be to have an offset of 4. Oh, interesting. What's happening now? Too few arguments to function call. What is the test CC? How did the test get in here again? Get out. Okay. And please deploy it to my address. It deployed it to a different address. Damn it. Deploy it to my address. Did you again get bigger? It again got bigger by a few bytes just because I have 4 now instead of 0. You know what? I'm gonna extend you for another 100 bytes, and for this one 100 is actually a lot. So this will give us some leeway. Is that the word? I don't know. Anyway, deploy it, please. It's just 3 transactions. It's so fun. I love it how this is just 3 transactions to deploy a program. So anyway, we deployed it. Let's run it with this 42 here. App transfer, which gets confirmed. This is literally just me playing around now. Okay, now it transferred 0. That's what I would have expected in the beginning anyway. Again, it doesn't fail or anything. It uses 2 more compute for some reason, because it needs to step further along in that vector, or in that array, in that pointer. This is fun. But then it reads 0, right? And so it transfers 0 Lamperts. So my instruction data was not really read. Okay, so I mean, I'm clearly doing something wrong. I'm getting the instruction data in there. Also, the Explorer tells me that is working. I just don't manage to... Wait, that's the wrong program. Just don't manage to read it. Maybe this. What happens if we do this? It's so fun. It's so quick to deploy. I can easily test like this. And this is still a bit annoying that I need to always copy that in. Plus this very, very big. Still 0. Let's add some logging as we learned in that other example. Sol log array. Log me the entire input array. Array and length. Well, I don't know the length. 4. I don't know how to find out the length. Source buffer containing serialized input parameters. Wait. Input parameters sounds more like parameters including the accounts. Wait. Params. Oh, the params has a data. It's being deserialized for me so neatly anyway. I have the accounts and I have the data. Why do I... Oh, stupid me. But yeah, gotta learn. We don't need that input. That input just goes into those parameters on some magic way that I don't understand. Now I get it. The sol deserialize, that takes the input and writes the parameters. And it expects this amount of accounts, so this size. That makes sense. And then if that's not successful, so if that's false, then we return an error. That does the thing. That's not just a check, that's the actual deserialize. Now I get it. Okay, sorry. That makes sense. But then here we have the parameters and we can just say params dot data at 0. Haha, and then we log the amount. No logging. Forget the logging. This is certainly not going to do the thing that I want. I can almost guarantee you that that's not going to do the thing that I want, but I want to see what it does. So we have the params data, and then we access that. So make and deploy. For real? How big did you get now? 2,900. Crazy. Another 400 bytes just because I'm now. Oh no, because I have static strings in here. Yeah, that's a lot of bytes. I agree. Extend for another 100 bytes or another 1,000. I don't care. I have enough Sol on DevNet anyway. I don't want to deal with this again. Deploy me this. Okay, and now we run it. Got an access. But did you see size of 42? So it read the thing correctly. I just get an access violation because I'm trying to read 42 bytes when I just have so many. So this is the amount of characters I should print, I guess. I mean, I don't know why I have that amount in here anyway. See, that's what it does. It does a sol log with the underscore of this string and then the length of this string. And before I tried to give the length manually by myself. It's still a bit more complicated to get the Lambert string in there. Anyway, logging is stupid anyway. It just costs CUs. Let's not do it. But yeah, I can get the 42 from here and then send the 42 Lambert. This works now. Check it. Make, deploy, run. There you go. Confirmed. And here we have it. 42 Lambert sent back. Nice. And it just took us 105 compute units. This is pretty efficient, I must say. Again, we still just used 1 byte. So it's not gonna work if I have, if I wanted to send 300 Lamberts, that's how I would do it, because 256 plus 44. And there's easier ways to write this in a little endian, but whatever, I'm a nerd. And this would just send me the 44 Lamberts now because I'm ignoring the other bytes. So I'll need to fix this here. Also, but first, I want to know what happens if I have no input data. Because that was the thing that we tried with the other program. What? Did I run out of Lamberts? Oh, it's because I ran out of Lamberts. Oh, it's already failing because of... Okay. Get me a bit more Sol to play around with. Let's do it again. Yeah, see, this is not failing me. This is just, I'm reading data somewhere. I'm curious how many Lamberts it transfers now. It transferred 200 something or 100 something, because whatever I read there, the 1 byte, there was something there. I don't know what I read. I read something. I didn't do any checks. Right, and that's the issue. In Rust, we would have found out that there is no index 0 of the parameters. But here we just, whatever is at the memory location there, where I'm trying to go, we take it. So, programming in C is more dangerous. I do recommend, especially if you're a beginner, that you do it in Rust. But if you're a pro in C, go ahead. Or if it's just a hobby project or something that is not really relevant, that doesn't need to be audited, or that doesn't need to be secure, then, play around with C. But I'm just saying, it is also more dangerous to program in C. Just putting that out there. Way more efficient, but mainly more efficient because we skip all the checks. Great for efficiency, bad for security. Yeah, anyway, so if I want to fix that to actually read a U64, how would I do that? There must be something like, all right, C is complicated, but that's the way it goes. We define the amount. We copy into the amount my data, and we start at 0, so that's fine. Size of amount. So that should be 8 bytes that it copies. We can't make it const since we write it. Yeah, there we go. And then that should also work, transferring my 300. Let's see. Nope, it doesn't like the mem copy. Call to undeclared function mem copy. Standard input output. I think that has the mem copy. Oh, it's in string? Mem copy is in string? I mean, I'm sure string has a mem copy as well. That's probably not the one I want, but maybe. Sure, we take the mem copy from string. Let's do it. Deploy it. Wow, we need 4 transactions now. Did you see that? We needed 4 transactions to deploy this. But then we can run it. Transaction simulation failed. Sum of account balances before and after instruction do not match. What am I fucking up here? This is fun. I mean, it gives me success, but then we're losing Lamperts, or we're creating Lamperts or something, apparently. I'm saying minus amount and I'm saying plus amount. Is this leaking something? Is the amount changing in between those two? C is fun. I mean, is fun. Oh, wait. I know why. Because I obviously have an underflow and possibly an overflow, because I'm still reading random data. Remember, I'm not having any input data. So let's get that back and also make sure that we have enough zeros here. 1, 2, 3, 4, 5, 6, 7, 8. That's what we need. That's a U64. And now we have enough zeros here that it doesn't over or underflow. Because if it underflows, obviously we're creating Lamperts and the runtime does not like this. So if we execute this now, there we go. That's better. And this will actually work and transfer me my 300 Lamperts. Did it do 300? No, it did. Yes. Yes. That's why it's 7 and the 2 zeros here are gone. It did do 300. Sweet. And it only took 165 compute units. We are getting more expensive in terms of compute, but we are doing more complicated things now. Actually reading input data and whatnot. Yeah, see, that's the input data, which I interpret as a U64. It's cool. I mean, I like it. I like what we can do. I like how little compute it takes, and it doesn't seem too difficult. Like, give me a few days and I will get used to writing Solana programs in C. Would I recommend that to everyone? Probably not. I would probably only really recommend that if you really want to be efficient and use as few computes as possible. But then you need to think about all the edge cases. You need to think about all the memory accesses because they're not checked. And you need to think about all the overflows and underflows that can happen. Obviously, with great power comes great responsibility. That's what this comes down to. It's great that we can have full control over what we check, because C doesn't do any checks. If you write the code that just accesses some random memory somewhere, C will do it gladly for you. And potentially it results in a seg fault and the program will crash on you. But potentially it just reads some random data that it finds there. So that's the fun thing about C. But it's also, it's dangerous, but definitely more efficient. Like, yeah. I think I made my point. You can write programs that use much fewer CUs, that are much smaller in size, so we need less rent for on-chain state. So our programs are smaller, they're faster, or they're more efficient. We can have more transactions in one block if my program is efficient. That's why we want to do those things. That's why we're optimizing for CUs. Just be aware that you don't over-optimize and make trade-offs in terms of security. If you're unsure, it's safer to develop in Rust. Obviously, you can also make mistakes there. It's just easier to make mistakes in C. And guess what? It's even easier to make mistakes when you're writing assembly code. So before you write assembly, I would recommend that you do it in C. But assembly could be even more efficient and even more difficult. So I might want to look at that in a future video. Make sure you are subscribed that you don't miss this. Like this video if you learned something. Watch some other ones while you're here. And I just wish you good luck on your Solana development journey. Let me know if you want me to do an actual program in C, like a bigger project with like an actual use case. We could do that. We just scratched the surface a little bit of what is possible with C. I assume that everything that we do in Rust is also possible in C. It's just written differently. So we just need to learn how that's done. It's just done a bit differently, you know. But it's all in that header file and you could figure it out yourself. Or if you want to, I can look into it and make another video. Let me know in the comments if I should do that. And I'll see you in my future videos. Enjoy coding in C. It is fun. I admit this is fun that we can do this. I like C. I just also like Rust. Probably even more. Okay, bye.